Today I will be going over Target 8 and 9 homework. I did highlight a couple things on here to make sure that we're not just graphing these problems, but we're also talking about their transformations and their x and y intercepts. So problems 1, 2, and 3 are all in vertex form where all have those parentheses squared. So first thing I'm going to do is I'm going to pull my vertex out of my equation. Remember, it's called vertex form because it has the vertex in it. We always do the opposite of what's in the parentheses and then what's on the outside. So I have my vertex start at +1, +1. I need to list my transformations then. So my vertex tells me 2 of those. The x value of my vertex tells me that my graph is moving right 1. The y value of my vertex tells me my graph is moving up 1. Then we always want to look at our a value. My a value here is just a -1. So that negative is going to tell me that my graph's reflected. So I know it's going to be opening upside down. There's no stretch or shrink in this one because my a value is 1. I need to find my x-intercepts. To find my x-intercepts, I always set my equation equal to 0. So 0 equals negative x minus 1 squared plus 1. I'm going to use the square root method, so I want to isolate everything that's squared. So I'm going to subtract 1. -1 equals negative of x minus 1 squared. Divide by -1 on both sides, and 1 equals x minus 1 squared. I'll take the square root now of both sides. The square root of +1 is just 1. So I have plus or minus 1 equals x minus 1. When I add 1 over, I'm going to get a +2, and I'm going to get 0. So my 2x intercepts are going to be at 2, 0, and at 0, 0. For my y-intercept, I always plug in 0 for x, but on here I can see I already found my y-intercept on my graph. 0, 0 is both an x-intercept and a y-intercept, so I know my y-intercept is also at 0, 0. To finish graphing this, I need to get 2 more points on there, so I'm going to use my 1, 3, 5, 7 rule. I know my a value is -1, so that's going to make it -1, -3, -5, -7. Be careful on how this graph is counting. You'll see it's actually counting by halves here. So from my vertex, when I go down 1, I need to go down 2 boxes all the way down to 1. Same with going right and left, we're going to have to go over 2. I see I already have those points graphed for my intercepts, so from there I'm going to go down 3 over 1 and down 3 over 1. I have my points. Connect your graph. Make sure it is curved. Number 2, my vertex here, pulling it out from the equation, opposite of what's in the parentheses, so a +4, same as the outside, so a +2. That tells me then my graph is moving right 4 and up 2. My a value here is a +1, so it's not getting stretched, and I don't have a reflection since it's not negative. Solving for my x-intercepts, I'm going to plug 0 in for y, so 0 equals x minus 4 squared plus 2. Subtract 2 over, -2 equals x minus 4 squared, and then I take the square root. Since I'm looking for x-intercepts, I know I can't have imaginary x-intercepts, and I have the negative underneath the square root, so that would give me an imaginary number. This tells me then I have no x-intercepts. So my graph's never going to cross that x-axis. I can still solve my y-intercept. We will always have a y-intercept. So for my y-intercept, I'm going to plug in 0 for x. So I have 0 minus 4 squared plus 2. 0 minus 4 gives me -4, so -4 squared plus 2. 16 plus 2 is 18. So my y-intercept is at 0, 18. Unfortunately, that's also not going to fit on my graph. So the only point I have right now is my 4, 2, but I can use my 1, 3, 5, 7. My a value here is 1, so I don't need to multiply those by anything. So from this point, I'll go up 1, right 1, and left 1. From those points, I'm going to go up 3, right 1, and up 3, left 1. So I have the 5 points on my graph. Those lines in between were just there to help me count. You do not need to have those on your graph. Number 3, my vertex here is going to be a -2, opposite of what's in the parentheses, and a +4 for my y value. So I'm at -2, +4. That tells me my graph is moving left 2. It's moving up 4. I have an a value of -2. The negative tells me my graph is reflected. And the 2 tells me that my graph is stretched. So we know this graph is going to be skinnier than the other 2 that we have done. To find my x-intercepts, I plug in 0 for my y. Knowing that my graph is reflected, I know I'm going to have x-intercepts because my graph has to go down from there. So I'll start by subtracting 4 over. So -4 equals -2, x plus 2 squared. Divide by -2, and I get 2 equals x plus 2 squared. Taking the square root, not forgetting to put the plus and minus in front of that, I have plus or minus the square root of 2, since we can't simplify that, equals x plus 2. I'll subtract 2 from both sides. In order to do that, I'm going to have to use my calculator. This way I can approximate it with a decimal. So the square root of 2 minus 2 tells me my first x-intercept is at -0.5850. Then I'm going to do negative square root of 2. So the negative square root of 2 minus 2 tells me my other x-intercept's at -3.41, 0. So we can approximate those two decimals. Again, we can't expect you to have it absolutely perfect, but in between 0 and -1, and in between -3 and -4. To find my y-intercept then, I'm going to plug in 0 for x, so y equals -2, 0 plus 2 squared, plus 4. 0 plus 2 is 2. 2 squared is 4. 4 times -2 is -8. -8 plus 4 is -4. So my y-intercept here is down at -4. I can use that axis of symmetry or that reflection point to know I'm going to have another point. Connect those. You could also use your 1, 3, 5, 7 pattern. Just make sure here you multiply it by -2. On the bottom, number 4 and 5 are a review of solving with our square root method, which is what we've been doing here to find our x-intercepts. So I need to isolate x squared, so I'm going to subtract 7 from both sides. So 49x squared equals 25. Divide both sides by 49 to get x squared by itself, and x squared equals 25 over 49. We'll take the square root of both sides. Don't forget plus and minus. Remember, when we square root a fraction, we can think of that as the square root of the top over the square root of the bottom. I know the square root of 25 is 5. I know the square root of 49 is 7. So my answer is x equals plus or minus 5/7. Number 5, the first step in order for me to solve this is I need to get 2 out of the denominator. So I'm going to multiply both sides by 2. So then I'm left with 2b squared plus 2. My other 2's cancel each other out, equals -26. I'll subtract 2 from both sides. So 2b squared equals -28. Divide both sides by 2, and b squared equals a -14. So we need to take the square root. Make sure you add the plus or minus in front of that. Couple of things here. I have the negative underneath that square root. Remember, we can pull that out using our I. 14, I could split into 7 and 2, but neither of those are perfect squares, and they can't be split any further. So we're done here, and b equals plus or minus I root 14. Please make sure that I is after that plus or minus and not before. On the back, we have target number 9, so now we're graphing in that standard form. We no longer have those parentheses. Remember, in standard form, to find that axis of symmetry or to find the x of the vertex, we're going to be using that equation x equals negative b over 2a. So for number 6, negative b is actually going to be a positive 2 over 2a. Well, 2 times negative 1 is negative 2. So my x value, or my axis of symmetry, is going to be at negative 1. And that's also the x of my vertex. So to find our y of the vertex, remember we always plug that into our equation. So y equals the negative of negative 1 squared. Don't lose that negative from the equation in front of the parentheses. Minus 2 times negative 1 plus 3. Well, I know negative 1 squared is 1. 1 times negative is a negative 1. Negative 2 times 1 is positive 2, and then we have plus 3 at the end. So negative 1 plus 2 is 1, 1 plus 3 is 4. So my vertex is at a negative 1, positive 4. Last but not least, I need to find my intercepts. So in order to do that, you can either factor or you can use the quadratic formula. So on this one, I'm going to choose to factor. The first thing I'm going to do is I'm going to factor that negative out. So I have y equals negative x squared plus 2x minus 3. I'm going to replace that y with 0 because I know for my x-intercepts, my y value always has to be 0. So now I'm looking for two numbers that multiply to negative 3 and add to 2. I know that's going to be a positive 3 and a negative 1. Setting those equal to 0, I get x equals negative 3, so I have an x-intercept at negative 3, 0, and I get 1 at positive 1, 0. Remember, we always set these factors equal to 0 in order to solve for that. The negative in front is not going to affect those intercepts. That just tells me that my graph is reflected and it's going to be opening down. Our y-intercept, remember, is always your constant in standard form. So my y-intercept is at 0, 3. I can use that axis of symmetry to reflect that point across. And now I have my 5 points on my graph. Number 7, starting by finding our vertex, we're going to use negative b, so negative 4 over 2a. Well, 2 times my a value of 2 is 4. So again, I'm going to get negative 1 for my axis of symmetry, and I'm going to get negative 1 for the x of my vertex. I'll plug that in to find the y of my vertex. So 2 times negative 1 squared plus 4 times negative 1 plus 4. Negative 1 squared is 1, so 2 times 1 is 2. 4 times negative 1 is negative 4 plus 4. So I get a y value of 2 for my vertex. So my vertex is at negative 1, positive 2. Looking at this and knowing that my a value is a positive number, I know my graph has to be opening up somehow. If my graph is opening up, it's never going to touch this x-axis. So I know I'm not going to have any x-intercepts here. So I don't even need to solve for them. If I did try to solve for them, I'd end up getting an imaginary solution. So if you can tell from your graph, you don't even need to stop. You don't even need to solve for them. So I'm just going to write that we have no x-intercepts. We'll always have a y-intercept. I know my y-intercept here is at a positive 4. I can reflect that to get another point at negative 2, 4. I still am missing points, so I'm going to use my 1, 3, 5, 7 pattern. My a value was 2, so remember we have to multiply all those by 2. So 2, 6, 10, 14. Starting at my vertex, I already have my points from going up 2 over 1 and up 2 left 1. So my next value is 6, so I'm going to go up 6. So 1, 2, 3, 4, 5, 6 over 1, up 6 over 1, and now I can see the shape of that graph. Number 8, again, starting with our vertex, trying to find that x value. So negative b, or negative 4, over 2a. Here my a value is negative 1, so 2a is going to be negative 2. So my axis of symmetry is x equals 2, and the x of my vertex is 2 also. We'll plug 2 into our equation, so we have y equals negative of 2 squared plus 4 times 2 minus 8. 2 squared is 4. We need to make that negative, so I have negative 4 plus 8 minus 8. So my y value of my vertex is negative 4. I know that this graph is also being reflected, so it's going to be going down. If this graph is going down, then it's not going to ever cross the x-axis. So again, I'm not going to have any x-intercepts. But I do have my y-intercept, always your constant in standard form, which is negative 8. So my y-intercept is at 0, negative 8. I need to finish graphing this, so I need to get points in between. You can reflect that. We can use our 1, 3, 5, 7 pattern. So that tells me negative 1, negative 3, negative 5, and negative 7, since my a value is negative 1. So down 1 over 1, down 3 over 1, which matches my y-intercept. And we have our last graph. Down on the bottom, 9 and 10 are a review of target 5, completing the square. Remember, when we complete the square, if you want to draw your shapes, you're more than welcome to do that. I'm going to start always by adding my constant over. So a squared plus 6a equals 8. We have to take half of our middle term, which is 3, and then we had to square it, which is 9. That's the little square that we had to add to the one side and the rectangle we added to the other. Now I can rewrite this as my binomial squared, always our variable. Whatever your middle number was divided by 2, in this case a positive 3 squared, that gave me one side of the square, and that equals 17. Now, it wants us to solve this, so we need to continue using that square root method. So I'll take the square root of both sides. So I have a plus 3 equals plus or minus the square root of 17. We can't simplify 17 at all, so we're just going to leave it under there. I'll subtract 3. 3 is not a like term with the square root of 17, so my final answer is negative 3 plus or minus the square root of 17. Let's look at B. So again, my first step, subtract 45, because we always want to move our constant to the other side. So b squared plus 18b equals negative 45. Take our middle term, 18, and divide it by 2, so I get 9. And square that, and we're going to add that to both sides of our equation. I need to rewrite my left-hand side as binomial squared, always our variable, our middle number divided by 2 squared, equals, on our right-hand side, we need to combine those, so negative 45 plus 81 is going to give me 36. To solve, we'll take the square root of both sides. I get b plus 9 on my left-hand side, plus or minus the square root of 36. Well, the square root of 36 is 6, so I have plus or minus 6. Subtract 9 from both sides. Be careful here. Positive 6 minus 9 is negative 3, and negative 6 minus 9 is negative 15. Please come in if you have any extra questions over the homework.